Today we're going to continue with polynomials. First, we're going to determine if a binomial is a factor using the factor theorem. Then we're going to write polynomials satisfying given conditions and determine the roots or the zeros. The factor theorem says that if you have the factor of a polynomial, then when you plug that number in, the answer will always be 0. So to do this, you simply take out the number and plug it in. See if it's 0 or not. So here's our first example. They gave us the factor x plus 1, and they claim that it's a factor of x squared minus 3x plus 1. The x plus 1 is in the x minus a format. When you take the 1 out, remember the rebellious numbers, you always switch the signs. So what we're going to be substituting is a -1. Remember to always use your parentheses when you are substituting. -1 squared, negative times negative. When we simplify this, we come out to 5. So we would say, no, x plus 1 is not a factor. Here's another one. We're going to do the same steps. We have x plus 2 inside. Remember, when we substitute, we use the rebellious numbers. So we're going to take the -2. Why? Because when I solve this, then my answer will be -2. Always use parentheses, then go ahead and simplify. After we finish simplifying, we get an answer of 0. So we would say, yes, x plus 2 is a factor of our function. We'll use this a lot later. Right now, it's good to know. Let's do one review of a factoring problem. We have 8z squared minus 4z plus 10z minus 5. First thing you need to do is combine your like terms. Now that we've combined like terms, we have an a value of 8, so we're going to use the happy face method. We know that the inside is going to be a plus and a minus. Basically, your happy face is winking at you because of the -5 at the end. I also know that the only factors of 5 are 1 and 5. And I put the 5 next to the plus because the middle term is positive. The factors of 8 are 1 and 8, 2 and 4. So I put the 2 so it multiplies times the 5, and the 4 so it multiplies times the 1. Now we're going to go ahead and check that. 5 times 2x is 10x. 4x times -1 is -4x. And if we did it right, our tongue will come out to the same answer as the middle term. 10x take away 4x is 6x. Yes, my middle term is 6x, or in this case, z. So my factors are 4z plus 5 and 2z minus 1. Now, if you make the same mistake I did and write x's instead of z's, when you type this into a computer, it will automatically mark you wrong. So make sure you're using the correct variable. What if they already give you the answer and they say work backwards? The zeros, or the solutions, are -2, 2, and 4. But what they want us to do is to write the polynomial. Now, this problem is asking for simplest form. This is one of the easiest. First, you put the zeros into factors, or into their houses. Remember the rebellious numbers, we're switching signs. Then we multiply, and if 0 is a factor, we're going to multiply everything by x. The zeros are -2, 2, and 4. My factors are going to be x plus 2, x minus 2, and x minus 4. We simply multiply these. The easiest to multiply are going to be the x plus 2 and the x minus 2. Most of you can probably do that in your head simply because you should see that as a difference of squares. But we'll go ahead and do it the longhand just to refresh your memory. You multiply just like you were in elementary school. Put one on top of the other and multiply straight up. -2 times 2 is -4. Then -2 times x is -2x. Next, you need to make sure you put a placeholder, and then you multiply all over again. X times 2 is 2x. X times x is x squared. Then, our last step is always to combine like terms. -4 plus 0 is -4. -2x plus 2x cancels each other out. And x squared plus nothing is x squared. So we have x squared minus 4 when we multiplied x plus 2 times x plus 2. Now we need to do it again with the x minus 4. Now we're going to do it again by starting off with multiplying the negative 4 times the negative 4 to give us positive 16, and the negative 4 times the x squared. Now, since there's no x term here, I'm going to leave space for the x term. That gives me a negative 4x squared. Make sure you put your 0 as a placeholder. Now we're going to multiply the x times the negative 4 and the x times the x squared. The x times the negative 4 is going to go where the x column should be, and that's why we left a placeholder in the last one. Now x times x squared gives me x cubed. So again, I need another placeholder for the x squared column, and I put x cubed there. Make sure you're lining up like terms together. Last step is to combine those like terms. Gives us x cubed minus 4x squared minus 4x plus 16. Now this is a polynomial in the simplest form with the zeros of negative 2, 2, and 4. Now this problem gives us some extra information. It tells us when we substitute f of negative 2 in, we should have an answer of negative 18. So we're going to have to add an extra step at the end. The first steps are the same. Now they tell us it's a third degree, which means we're going to have an x cubed in our answer. So we do all the steps the same. We have the factors, or we have the zeros or the solutions of negative 1, negative 3, and 4. So when we write the factors, we switch their signs. Multiply the first two factors by putting them on top of each other. It doesn't matter which two you start with. I'm just going to go in order. We start by multiplying straight up and then straight across. Don't forget your placeholder. And then we do it again. X times 3 is 3x and x squared. Remember, your last step is to combine like terms. Now I take this solution and I rewrite it to multiply times the other factor, x minus 4. And then I multiply the negative 4 times the entire top. Again, don't forget that placeholder. And now the x multiplies times the entire top. As always, our last step is to combine like terms. The x squared is canceled out, giving us x cubed minus 13x minus 12. Well, that is the polynomial in simplest form. But they didn't want it in simplest form. They gave us some extra information. So what we're going to do is simply substitute the f of negative 2, and we should have an answer of negative 18. So we write negative 18 is equal to some multiplier. We don't know. It's an a term. We're going to put an a. Then rewrite your equation with negative 2 being substituted in. Remember to always use parentheses when substituting, and now just simplify. We're left with negative 18 is equal to the a term times 6. Divide both sides by 6. Gives us the a term is equal to a negative 3. Now what do you do with this negative 3? You take that negative 3 and you multiply the whole thing which gives us a final function of negative 3x cubed plus 39x plus 36. Obviously, it's a lot easier if we don't have to find that last step, but most of your problems are going to look like this, where we have to figure out what the multiplier is. They basically give us the answer. We just have to figure out what that multiplier or that a term is, and then make sure you distribute it all the way through. Be careful of changing your signs. Let's do one more. It says find a polynomial of third degree. So again, it's going to be an x cubed with real coefficients that satisfies the following conditions. It says that we have a 0 of 0 when we have a 0 of 4 having multiplicity of 2. Well, remember, multiplicity means you have the same thing twice. So the 0 of 4 having a multiplicity of 2 means we have two answers of 4. So we're going to have two factors, and it's going to be x minus 4 and x minus 4. That satisfies that. The 0 that is a 0, I realize that sounds weird. It says if a factor is 0, then multiply everything by x. So that means our last factor is simply going to be an x. Let's multiply these out really fast. x minus 4 times x minus 4 gives us x squared minus 8x plus 16. Now, because the next one's not a binomial, it's just an x, I'm simply going to throw on the front and distribute it through. So our polynomial in this most simplified form is x cubed minus 8x squared plus 16x. But they told me that f of 5 is equal to 30. So now I need to substitute and figure out what the a term is. Remember to always use parentheses when substituting. So we're going to put the 5 everywhere you see an x. Now simplify. That gives us an answer of a is equal to 6. So we're going to take that a is equal to 6, put it in the front, and distribute. That gives us the final answer of f of x is equal to 6x cubed minus 48x squared plus 96x. Now we're moving on to solving by factoring. So we were just using factors and working backwards. Now we're going to solve by factoring, which should be much more familiar to most of you. First, we factor completely. We set each factor equal to 0 and solve. And the last step is to look for multiplicity. Now, we said in the last problem that multiplicity are roots or zeros that are repeated. So your multiplicity are roots or zeros that are repeated, and that's what we're going to focus on today. Find the zeros of the function. Now, this one, they were nice. They partially factored it for us, but they haven't factored it completely. So we're going to take these factors and split them up. We have x minus 1 squared. Well, x minus 1 squared is simply x minus 1 times x minus 1, and there's also an x minus 2. So we factored completely. Now, set each factor equal to 0. And when I say equal to 0, I simply mean write it equal to 0. That gives us x minus 1 is equal to 0. Another x minus 1 is equal to 0, and an x minus 2 is equal to 0. Now, most of you probably solved this in your sleep. We're going to add the 1 to the other side, and then we'll add the 2 to the other side. That gives us 3 answers, x equals 1, x equals 1, and x equals 2. Now, when actually writing the answers, you would say x equals 1 with a multiplicity of 2, and x equals 2. Sometimes they'll actually want you to say with a multiplicity of 1 because there's only one of them. Depending on what book you are working out of, it'll either say with a multiplicity of 1, or you just simply write the x equals 2. Here's another function. Now, this has been really hard to factor if we needed to do it from scratch, but we don't. They factored it mostly for us. So we're going to take these factors, split them up. I have an x minus 2 squared. Now, the 9 in front, that's not going to affect me at all because it's not a variable. If there was an x in front, that would be an answer. It's a 9. It's not going to affect me at all. So first thing I do is split up the factor, x minus 2. Now I can rewrite all of my factors and set them equal to 0. Now that they're factored completely, I already set them equal to 0. All we need to do is solve. So we're going to add 2 to the other side. Here we're going to add 1 and then divide by 6, and then we're going to have to take a square root. That gives us several answers. We have x is equal to 2 twice. We have x is equal to negative 1/6. Remember, subtract the 1, divide by 6. Then x is equal to 3 or negative 3. Again, we're going to add the 9 to the other side and take the square root. Whenever you take a square root, you get a positive and a negative version. Your final answer will look something like this. X is equal to 2 with a multiplicity of 2. X is equal to negative 1/6, 3, and negative 3. Here's another one, a little bit different, pretty similar. We have x minus 2 raised to the 5th power. Well, that means we're going to have 5 of these x minus 2s. Now, I'm not going to write them all out. We simply know it's a 5th power, so we're going to have a multiplicity of 5. X minus 2 is equal to 0. And then we have an x squared minus 3. It gives us x is equal to 2. On the bottom, we have to add 3 to both sides. X squared is equal to 3. When I square root it, there is no perfect square. So I'm actually left with the square root of a positive 3 and negative square root of 3. So our final answer will look like this. X equals 2 with a multiplicity of 5, because it had a fifth power on there, so which means we had 5 of them. And then x is equal to plus and minus the square root of 3. This one, they have not factored it for us, so we need to factor it. First thing I want to look for is a GCF. I see that I have a GCF of a 4, because there's a 4, and there's a 4 inside the 24. Also, we have a power of 4 on the x's. Once I take out my GCF, it becomes much easier to factor. Now I set each factor equal to 0, and I can solve. And that gives us x is equal to 2, negative 3, and it's equal to 0 because we had 4x to the fourth equals 0. Now I took the fourth root just to show, yes, that's how you can get rid of it, but what you're really looking at is I had 4x to the fourth. So technically I have x equals 0 4 times, which means I have 0 with a multiplicity of 4. So I get x equals 2, negative 3, and 0 has a multiplicity of 4. Notice there's 6 answers. I have to the power of 6. That means I had 4 zeros, and then a 2 and a 3 gave me 6 answers. Last problem, factor completely. Before I can factor, I need to move the 26 over. Now that my equation is set equal to 0, I can go ahead and factor it. The factors of x to the fourth are x squared and x squared. We know it's a negative in the middle but a positive at the end, so they're both negative. And the factors of 25 that are going to add up to 26 are simply 1 and 25. Now, I have a difference of squares in both. X squared minus 1 is going to break into x plus 1 and x minus 1. X squared minus 5 breaks into x plus 5 and x minus 5. You should recognize difference of squares, and you should be able to do them quickly in your head. Now you're just going to set each of these factors equal to 0. Solve for each of these, and you end up with x equals negative 5, negative 1, 1, and 5. There was no multiplicity, so if they asked for all of these, it will have a multiplicity of 1. Now notice I put these in smallest to largest. When you're answering these questions on a computer, make sure you are reading the directions as to how they want you to answer the questions. Sometimes the computer doesn't care, and sometimes they will ask from smallest to largest or from largest to smallest. Please be sure you are reading the directions.